Hello students, we move to the next topic, which is discrete time LTI system and linear convolution sum. What you should remember here is that this linear convolution sum is an important mathematical operation that will help you to find out what is the output of this system, which has a equation of h of n and an input x of n. So you can find out y of n if you know h of n and x of n. Now let us look into this system. One way of knowing what the equation of the system is to input a signal which is an impulse signal delta of n for x of n. So if I am going to put delta of n here, then at the output I will get y of n is equal to h of n. That is what is written here, that the output y of n is basically transformation of x of n, and in place of x of n, that means as an input signal, if you are going to give input as an impulse signal, the transformation of that will give you an output, and that output will be the same as the system. So that is one way of knowing what the system is. That is the reason why the system is called as impulse response, because this response is because of an impulse signal. So if you give an impulse signal, the response of that will be the system itself. Now, why we are learning this here is because what we are interested in is to find out, if we know what is x of n and we know what is h of n, is there a way to find out y of n? Generally people think that, okay, if I know x of n, h of n, then all I have to do is x of n into h of n and I should get y of n. What is there? Big confusion in it. But no, this is not correct, because time is acting here, and based on time the values will not come based on multiplication. So you cannot do simple multiplication in case of time domain, or when the signal is with respect to time. So we have to go for another mathematical operation, and we are going to derive that operation, and that operation is basically called as the linear convolution sum. So anyway, what is important here to learn from here is that the impulse response h of n of a discrete time LTI system. What is LTI system? LTI system stands for a linear time invariant system. A linear time invariant system. Now we have already studied what is a linear system, one which follows superposition and homogeneity rule, and time invariant system is a system in which the output does not change with time. And throughout your signals and system, as well as DSP, as well as in other future subjects, when you study engineering, you will be mostly dealing with an LTI system or a linear time invariant system. So whenever you see an LTI system, then you should remember that it is having a linear nature as well as it is a time invariant system. So the impulse response of a discrete time linear time invariant system is defined as the response of the system when the input is delta of n, which is an impulse signal. So if we know this, then we can derive an equation of y of n with respect to x of n, h of n, which is basically the linear convolution sum, and that is what we are going to do next, which is response of the system to an arbitrary input. So if you are having x of n and the system is h of n and you need to find y of n, how will you get it? So to understand the method of derivation of this, first we have to look into some of the properties of impulse that we have already studied. One is that if you multiply an impulse signal with an x of n, I already told you, if you would remember, that suppose if you are having a signal which is having many different different values, and suppose this is x of n, and suppose this is 0 and this is the time axis, And if you multiply it with delta n, now what is delta n? Delta n has only one value, and that value is at this point, which is 0 axis, only at 0. So whatever be the other values here and there, they will all get to 0, and all that you will be having is this value multiplied with delta n, which is 1, and so only this value will come as an output. That means only x of 0 will come as an output. And that is what basically this says, that if you are going to have an xn signal which you are going to multiply it with a sample signal, then it's as good as multiplying x of 0 with delta of n, which is basically x of 0 itself, because delta of n is 1. There is another rule in which we have learnt in in impulse, and that is, if you are having a shifted impulse, that means if you are going to have a signal, delta n signal, which is shifted, let us say it is delayed by some value k. So this is delta n minus k. So if you are delaying that, then all the other values will become 0, and only this value will get multiplied with this delta n, and you will get basically a signal which is x of k. That means only at this particular value of k you will get the signal, so the output will be x of k. So with an understanding of these two principles of impulse, we will move forward. Now we know that there is a signal x of n, and I will define that signal as having some value at 0, some value at 1, some value at 2, some value at -1, -2. Let me show an example here. Suppose you are having a signal which is, suppose 2, -1, 4. Then this signal, suppose this is the 0 axis. Now this signal can be written as a combination, as an addition of three different signals. The first signal being 2, 0. Okay, the second signal being -1, and the third signal being 0, 4. So what do you see? All of this place, what do you see? If you add this signal and this signal and this signal together, you will be basically getting this signal. So in a way, any signal which is having three components, you can split it up into three different signals having only one value each. See, here there is only one value which is 2, here there is only one value which is -1, here there is only one value which is 4. I have written this 0 here because I want to show where the axis is, where the 0 axis is. That's why I have written the 0. Otherwise there are only three values. So just like that, an x of n signal can be basically written as as a signal which is basically composed of three different signals like this. X of n can be given as an individual signal. Now, borrowing from this principle, if I am going to take from this principle, any value can be written as a multiplication of the original signal with delta n. The original signal with delta n, or the individual element with delta n. So if you are having delta n, that means you are talking about x of 0. If you are talking about x of k, you are talking about with x of k delta n minus k. So here each of these elements I am going to write it using this particular principle, wherein x of k is basically equal to x of k into delta n minus k, and based on that I will get this particular signal here. And now each of these individual signals, so this is one individual signal, this is another individual signal, this is another individual signal. So each of these individual signals I will write as an individual signal, and I will add each one of them. So I am having a summation. I am having a summation, and you can see in this particular summation that x of n, which I had written out like this, can now be written as a summation of all of these individual signals, just like I have done here. okay, where each one is basically xk delta n minus k, because if you remember I had said that each one I have written it in terms of xk delta n minus k. So x of n has been written as an addition of individual signals xk delta n minus k. So now if this is x of n and I want to find out the output y of n of a discrete time LTI system, then I know that y of n will be basically the transformation of x of n, where x of n is basically this equation, so I write that equation in its place. Now what I want you to remember, what I want you to look here is, see, x of n is a signal which is dependent on n, and the transformation is happening of x of n where x is also dependent on n, correct? In this part of the equation also the transformation should happen only when it is with respect to n. So here you can see it is with respect to k, so the transformation won't happen to this signal, it will only happen with this delta n minus k, where delta n minus k has n component. That's why the transformation, this transformation can now be written as having only in delta n minus k. Why? Because only delta n minus k has the n component on which the transformation will act. So the rest of the equation which is with respect to k has basically gone out. And what is transformation of delta n minus k? What is delta n minus k? Delta n minus k is an impulse signal. So if you would give an impulse signal, you will get the impulse response, which is basically the system. But here, since the sample, or since the impulse signal is delayed, the system equation will also be delayed. So from here that we have taken from this particular page where we had given this particular equation, if I am going to put n minus k, delta n minus k, then here also it will be h n minus k, and that is what is basically happening here. So now instead of this portion I will substitute h n minus k, and now you are having an equation, and this equation you can see is comprising of only x and h. And that's why we say that if we know what is the input signal x of n and we know what is h of n, we can find out y of n by following this equation, and this equation is basically called as the convolution sum. This is called as the convolution sum. Why sum? Because here it is summation. Why I am stressing on this sum is because this is for the discrete time case. When we will study a continuous time case, in that case instead of y of n it will be y of t, and that time this integral, this summation will not be a summation, it will be an integral, and that time I will call this as convolution integral. So when I say convolution sum, you must automatically understand that it is sum, that means convolution sum, and so it should be a discrete time signal. So this equation of convolution sum is basically written with a symbol that is star, and that star symbol is what we have drawn here. Let me draw it again. So this is the star symbol. So when you say that you are doing xn convolution with y of n, you are trying to convolute these two equations with this particular formula, and that is what is a very new equation for you, and that is something that we have to learn because that is very crucial. So in summary, we can say that in the above equation of convolution sum, the right hand side is defined using the symbol which is called as the convolution symbol. So now the output y of n will be input convoluted with the system, and the equation that we are having here is basically what I have written here. So now, since we have learned convolution sum, let us do a problem to understand, let us do a numerical to understand how convolution sum is done. I would request you to pause the video and write this question. So you can pause the signal and you can pause the video, sorry, and you can write the question. The question is, find the output of a system defined by its impulse response h of n and to an input given by x of n. X of n, I have to draw the arrow also. So this is the arrow, that means this is the value at n is equal to 0. Now I have to do, obviously if I want to find out output, we have seen just now that the equation of y of n is x of n convolution with h of n, whose equation is given here. Now this equation I am going to slightly rewrite, because you can see everything here is with respect to k, and here we are having an n. So now I am going to say that, you know, it's all with respect to k. So now I am going to draw the time axis as k and not as n. So in that case, I will just try to put this k forward and n behind, and now I am having the equation basically written like this. And this is the equation that I am going to always use. This yn is equal to this equation I will keep on using. I will use because that is what is going to, you know, get the output. So first what I have to do is I have to define x of k, that is correct. I have to first define x of k. X of k is already, you know, x of n is already given, so all you have to do is basically rewrite x of n, but now with respect to k, and that with respect to k I have drawn here also just for reference. Now there is no need that always you will have to draw it, but I have just drawn here, where you can see that with respect to 0 axis it is half, then you are having a value 1, then minus half. Similarly in minus 1 you are having the value minus 1. So that I have drawn as such. Next I have to draw h of k, because I have to draw h of minus k. So before I draw h of minus k, I have to draw h of k. H of k will come from h of n. So I will rewrite that equation here, and this is my h of k. So here there is no arrow that has been put, but we know that if there is no arrow, then the first element is at 0, and that is what I have done by just putting an arrow here. And next I have to draw h of minus k. Now what is h of minus k? If you remember from signal operation, h of minus k is time reversal. That means whatever is in the positive time axis, we are going to flip it and put it in the negative time axis, and whatever is in the negative time axis, you will put it in the positive time axis. Now here you can see that h of k is basically having a value at 0 and at positive time axis. What I will do when I do h of minus k is I will flip all these positive values, I will flip to the other side, and that is what is done here. So you can see 1 goes this side, and that is what is here. Minus half goes beyond that in the left side, and that is what is here, and half that is here is going beyond that, and that's why you are having half here. So what we have done is we have basically flipped the time axis. That h of k is drawn here. If I want to flip it, what I will do, this I will take what is in 1, I will take at minus 1. Whatever is the value at 2, I will take at minus 2. Whatever is at 3, I will take it at minus 3, because that is what is basically flipping. So whatever is k, I am going to put it at minus k. So that is what is going to happen when we flip the signal. Now we have got these two signals, x of k and h of minus k. And now to carry out this equation, I will show you by showing it with respect to movement. So you are having the equation here. Now if you remember, this is the convolution equation, and the convolution equation basically it is minus k plus n. Okay, now according to what we have just now seen, the arrow or the 0 axis is at minus, not minus, at 1 by 2. So that I will draw here. So this is minus 1 by 2. Now this is going to be aligned, x of k and h of minus k. This is h of minus k right now. Okay, h of minus k. Now I am going to shift this. And as I am going to shift it, because why I am going to shift it, because I will start with h of minus k, but I have to keep on putting value of plus n for finding out what is the value of y of n. So if I want to find out what is the value of y of n at some particular value of n, then I will have to keep on changing the values of n here. See, look at the equation. In this particular equation, if you want to find what is y of n, you have to keep on changing the value of n here, because rest all things is k, and that is not going to change, it is only going to add. So multiply and add, that is what is going to happen. But whatever is the shift in h of minus k, that is going to give a different output of y of n every time with changing values of n. Now if you remember, this operation, this signal operation of h of minus k is basically h of minus k plus n is basically time shifting, and generally when we write plus, it means that we are advancing in time, so we should generally move in which direction? We should move in the left direction. But since the time axis is reversed, I already have taught you that since the time axis is reversed, now if we are doing a plus n, it means that I am going to move in the right direction. So when for positive values of n, for here also for positive values of n, you will have to move h of minus k towards right direction. For negative values of n, that means for here if it is minus n or the values of n are negative, then for that you have to move to left direction. With this I will start the convolution operation. So let me start with a 0. So if I am going to put here, the value is going to be plus 0. Okay, that means it is h of minus k plus 0, which is as good as h of minus k. So h of minus k multiplied with x of k. So both of these are already written here, and I have to now multiply both of this. So when I am going to multiply, see, only these two values are happening to multiply and give some value, because here the value is 0, 0. So like that, if the values are zeros, then it is as good as basically saying that the value answer will be 0 for this. Whereas here if I am going to multiply half and half, it will be 1 by 4, and minus 1 into 1 is minus 1. So minus 1 and 1 by 4, and what I have to do is I have to add all those values. Here all it will become 0. Correct? Here also it is going to become 0. So if I add up all of these values which is given up by this summation, then what will I get? I will get this as minus 1 plus 1 by 4 is minus 3 by 4. So for value of y of 0, the value y of 0 will be minus 3 by 4. Okay, this is for n is equal to 0. So as shown here, I have drawn x of k, or I have written x of k, which is this one, and I have written h of minus k plus 0, which is this one, and based on that, when I calculated by putting value of n is equal to 0, I got basically y of 0, which is this. Now you have to look at how I am moving for each and every value. Okay, so first I will try to find out the negative values. That means next I am interested to find out what is y of minus 1. I have already found out y of 0 is equal to minus 3 by 4. Now I want to find y of minus 1. That means here instead of n, I will give minus 1 value. Here also instead of plus n, I will give minus 1 value. So let me put as minus 1 and this also as minus 1. So I have to draw what is h of minus k minus 1. And you know that if I am going to give minus 1, generally it is delayed. Delayed means I have to move the signal towards the right direction, but since the axis is already reversed, minus means I will have to move towards the left direction. So this is not the direction, I will move in the left direction, and I will move by one step, because previously it was 0, now it is minus 1. I have to move one step towards the right. So what I am going to do is I am going to take this, I am going to move one step towards the right. Now when I have moved one step towards the right, see, I will now not look at where is the 0, because this axis, the 0 is always going to be wherever it is, and only this value is going to come, because you are shifting the values, you are not shifting the time axis with it, you are shifting in the time axis. That's why the arrow will remain there with aligned with this arrow. And now when I do the multiplication of these two, you can see that here by default the values here are going to be all zeros, correct? Here the values are all going to be zeros, and here also it will be 0. So if I am going to multiply both of this, what is the value that I am going to get? I am going to get, here it is going to be 0, 0, 0, whereas here it is going to be minus 1 by 2, here it is going to be 0, 0, 0, all the way up to 0. So this will be adding up of all of this signal, which comes out to be minus 1 by 2. So y at minus 1 will be minus 1 by 2. Okay. So I have found out y of minus 1. Next I have to find y of minus 2. So instead of minus 1, I will put minus 2 here. Everywhere I will put minus 2. So this is going to be minus 2, minus 2, minus 2. So if I have to do minus 2 again, I will have to move this one towards the right direction, left direction. You remember why? Because when the signal is reversed and you put minus, we have to move towards the right direction. Now if I move one step towards the right, now what do you find? Now I find out that the signal is going to give me multiplication. If I'm going to do multiplication, then there are no values here, so it will be all zeros. Here also the value is completely zeros, so the multiplication will also result in zeros. And so this answer is going to be 0. So I can write, there is no problem if I don't write, but if I write, but there is no point, because see, now for all the other values of n, let it be minus 3, if I keep on moving this side, the answer is always going to be 0, isn't it? So I will stop, for the negative axis, I will stop at this value, because beyond that I am not going to go. So this is y of minus 2 is going to be equal to 0, so I am not going to take that. And now I have to move towards the positive axis. So if I have to first find, again if I have to find y of 1, then obviously I have to make the changes. But before I do that, remember I have to bring back the signal to original h of minus k, and h of minus k is basically where? H of minus k is basically here. So I will take it all the way back and I will bring it where the original signal was. So this step you should not forget, otherwise again you will make a mistake. So this is right where h of minus k, so this is right now h of minus k, sorry, this is h of minus k. Okay, this I have brought it back. Now I have to basically try to find out y of 1, so this I will change, this should be plus 1. So again I will write that this should be plus 1, so here it should be plus 1, and here also it should be plus 1. So if it is plus 1, I will have to move one step to the right, because for plus I have to move this side. Why? Because the signal is already reversed in time, so if it is plus, it means I have to move towards right. So now if I am going to multiply, what will you see? I will get minus 1 into minus 1 by 2, which is 1 by 2. This will become 1 by 2 into 1, which is 1 by 2. This is again going to be 1 by 2 into 1, which is 1 by 2. The rest all values are going to be zeros. So it does not matter. I will get the addition of all this, which I will write here as plus 1 by 2 plus 1 by 2 plus 1 by 2, which is 3 by 2. So my answer of y1 will be 3 by 2, correct? So I have found out y of 1. Next I will again move this, so that I get for plus 2. So I have to find out the value for plus 2. So again I will put plus 2 here, plus 2 here, again I will put plus 2 here, and I am trying to find out y of plus 2. for which I have to again move this. So I will again select all of this and I will move. See, I'm not moving the arrow, I'm only moving the signal. Okay, I'm not moving the time axis, I'm only moving the signal. So now the multiplication of this will be, all the others will become 0. Here you will have minus 1 by 2, this will be minus 1 by 4, this will be 1 into 1, 1, this will be again minus 1 by 4. So if I'm going to add all of this up, I will get minus 1 by 2 plus minus 1 by 4 plus 1 plus minus 1 by 4. So if I add all of this up, you can see minus 1 by 4 and minus 1 by 4 will be giving minus 1 by 2, minus 1 by 2 and minus 1 by 2 will be giving minus 1 plus 1 will give me 0. So the value of y of 2 is equal to 0. So people might think, then should I stop here? No. See, you have to keep on moving until you repeatedly get zeros infinitely. Okay, so I will not stop here. So y of 2 is done. Next I have to do y of 3. So before that, let me rub off this one. And now I will put one step again. I will take this signal one step to the right. Okay, one step to the right. And now I am interested in finding y of 3, y of 3. So this is h of minus k plus 3. So now I will write here y of 3, and if I want to find out the value, so obviously multiplication of this, here it will become 0, here it will become 1 by 4, here it will be again minus 1 by 2, it will be minus 1 by 2, then again 0. So minus half and minus half will, if I try to add all of them up, I will get 1 by 4 minus 1 by 2 minus 1 by 2, which is basically minus 3 by 4. The answer will be minus 3 by 4, and this I will write it again. I will write it where? I will write it here. So this is going to be minus 3 by 4. So again I will have to move again one step. I will have to try to find out for the case of 4 plus 4. So y of 4 will be equal to h of minus k plus 4. So this will become again plus 4. So I have to move one step again. I have to move. So this is what is going to be. I have moved one step again to the right. And now if you are going to multiply, I will get 1 by 2 and minus 1 by 4, which if I am going to add, it is going to be 1 by 2 minus 1 by 4 minus 1 by 4, and that it will be equal to let me see if I am doing, no, this will become plus 1 by 4, correct? So this will be plus 1 by 4, which will basically give me 3 by 4. So if I try to find out y of 4, the value of y of 4 will be equal to plus 3 by 4. Let me use the color. So it is going to be plus 3 by 4. Similarly, I will do for the next case, which is for 5, which is plus 5. So if I am trying to do for plus 5, I will get 5 here plus 5 here. I'll get a plus 5 here. Again I will have to move the signal towards the right one step. And now if I am going to multiply, only these two are going to multiply, and the answer is going to be minus 1 by 4. See, I have not moved the arrow. Okay, minus 1 by 4. So minus 1 by 4 is going to be the answer for y of 5. So this is going to be minus 1 by 4. Minus 1 by 4. So this is minus 1 by 4. Which one? Y of 5. Now you can see I can try to go for y of 6. I can try to go for y of 6. But if I try to go for y of 6, which you can see here, if I try to go for y of 6, I have to move one more step, and one more step will basically make these two signals go out of the range of each other. And now as you keep on moving towards right, every time the multiplication is going to give you the answer as 0. So there is no need for further writing this. We will stop it here, and we will stop the values that we have written. We will stop it here. And now if I am going to name it, I will name that this is y of n, that is this is y of n. And now you have got the answer, and this answer is the convolution between x of n and h of n, which is done by this process. Now this, how to write this process, that is important. So as it is written here, I have first written what is x of k, h of k, then I wrote what is h of minus k. I have even drawn them. There is no requirement that as such you have to draw, but if you draw it will be good. And then I will keep on putting the values in this particular equation for different values of n, and I will keep on calculating. So here I have written y of 0. So for y of 0, what is the equation? And I have written x of k and h of minus k, and then I have done the multiplication, and I have got the value of y of 0 as minus 3 by 4. Similarly, for the next step, y of minus 1, I again write the equation, full equation. I give the shift towards the left side, and whenever I am moving out to multiply, I will always, since I am always going to keep this arrow here, I have to always fill up from the arrow. So I am going to put a 0 here, and I am going to move the signal towards left, and I am going to multiply both of this, and I am going to get the answer as minus 1 by 2c. Here it was h of minus k, it is h of minus k minus 1. Similarly, I went for h of minus k minus 2, where now the answer will come out to be 0. So I can see from here that if I move further left, the answers are all going to be 0. So I am not going to be now interested in y of minus 3 or any other values further negative. Now I am going to go for the positive values, which is y of 1. So just like I did there, y of 1, I am going to again start from here. I'm again going to start from here, and then plus 1 means I'm going to move right. So from here I will move the signal towards right, and that signal, when I have moved right, I will multiply, and then I will add, and I will find out what is the value of y1. Similarly, I will try to find y of 2. Again, I have drawn here, then I will try to find out the value of y of 2. So in each case I am drawing what the signal is going to be. In each case I have to see how I have got the signal. So this is how I will keep on writing the signal. So here I have missed out 0. If you want to write a 0, it is okay. If you don't want to write, it's okay. So here I am trying to find out y of 4, y of 5, and then I will totally write the signal here. So here, see, I have written zeros here. There is no point in writing 0 here. I can even avoid that, as I had done in this particular case. And now I have to put the arrow. Obviously the arrow will be at y of 0, which is basically this. So this is how we do the convolution. Now here, what you should remember, or what I want you to remember here very particularly, is that both these signals were having a finite length. Both these signals were having a finite length. So if this h of n is having a length of 4 elements, here also x of n is having a length of 4 elements. So there is a particular formula that is used. If x of n has a length of 4, let's say Lx, and y of n is the second signal, let's say it is Ly, it is also having a length of 4. Generally the rule that we have is Lx plus Ly minus 1. So in this case it will be 4 plus 4 minus 1, which is equal to 7. And you can see I have got the 7 values exactly here. So 1, 2, 3, 4, 5, 6, 7. I have got the 7 values. So the length is equal to 7. Sorry, I should have written here